Hi, today we will discuss the analysis of sequential circuits, and this is lecture 11. And basically, the analysis of sequential circuit, as we all know, we deal with two terms in this class. One term is design, and the other term is analysis. So basically, we start with the circuit description, right? And here is a circuit that we draw at the end of some sort. I don't know, something here. So this is the process of going from the description to the circuit is referred to as design. Now, the process of going back to from design to description is referred to as analysis. Okay, so what we are going to do in this lecture is more of the analysis, meaning that we will have the circuit and we will try to describe the sequential circuit. Now, the question now here, how do you describe a sequential circuit? So, um, before we took or we looked at how we described a combinational circuit. We had a circuit, for instance, and then what we did, um, we ended up saying, all right, well, F equals da 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 da. So this is more of the description. But how do you describe a sequential circuit? Okay, how do you do that? Well, for that, what we need to do is we will have to, because the sequential circuit has a specific, the specific case of including sequential element or memory elements, we need to be, or we need to invent a new way of describing the sequential circuit as opposed to the combinational circuit. The sequential circuit, the sequential circuit, we have here the combinational block, as we have indicated earlier in last lecture. Some of that output goes to memory element, memory elements, all right, and then the output of that memory element goes back to the combinational. This circuit has primary input or inputs and primary outputs. Okay. Now, to describe such a circuit, we need to talk about something called state diagram and a state table. Okay. So, what is a state diagram and what is a state table? Um, in the sequential circuit, it turned out that in this for sequential circuit, let's say, for example, for this, okay, so let's pick another, okay. So suppose I have a sequential circuit where I have two flip-flops. Here is one flip-flop, and here is another flip-flop. And those flip-flops, um, they get their outputs from some kind of combinational block. So this is the input here, and this is the input here. And let's say, for example, this one is Q1 and this one is Q0. So these are two flip-flops. And then the output of these two guys, they go back to the combination. And let's assume that we have an input X and an output Z. So in this circuit, I have the following information. The primary input for this sequential circuit is X. Now, I could have more than one input. I can have X, Y, A, B, C, D, but for this case, I have just X. And the primary output is Z. Now, and the states, okay, the state or the flip-flops, I should say, I'm sorry, the flip-flops that I have is Q1 and Q0. It turned out here we can take those flip-flops and talk about every value of those flip-flops as a state. Meaning, I have here Q0 and Q1. I'm sorry, let's say Q1 and Q0. And the combination of these guys is 0, 0, 0, 1, 1, 0, 1, 1. Now, every one of those, watch now, every one of those I will call a state. A state. A state of what? A state of the sequential circuit. So when Q1 and Q0 equals 0, 0, that is the state of the circuit. Now, when Q1 and Q0 equal 0, 1, that's another state. And when Q1 and Q0 equal 1, 0, that's a third state. And when Q1 and Q0 equal 1, 1, that's a fourth state. Meaning that if you have number of flip-flops, okay, equals M, then number of possible possible states equals what? Well, equals 2 to the m. Like in this case, I have two flip-flops, 1, 2, right? How many number of states I have? 1, 2, 3, 4 states. Okay, so these states are the states of the circuit. Remember, we did not talk about a state in the combinational circuit. We have to talk about it though in the sequential circuit because this is reality of this circuit. It has different states based on the values of these Q0 and Q1. Okay, okay. So now, then what? Then how can I describe this circuit? Now, to describe a sequential circuit, what we need to do is we need to describe it in terms of a state diagram. So now you will see that this is here my Q1 and this is here my Q0. Now, since I have two flip-flops, it turned out as I indicated earlier, Q1 and Q0, it turned out how many states I have? 0, 0, 0, 1, 1, 0, 1, 1. Now to describe the state or a sequential circuit, I need to plot what I call state diagram. Okay, so what a state diagram is? A state diagram is a diagram consists of the states in the circuit. Every every state here. So every circle here is a state. So this state belongs to here, and this state belongs to here, and this state belongs to this one, and this state belongs to this one. Beautiful. So how many states I have? 0, 1, 1, 2, 3, 4 states. Now, then what I do, I start having transition for these states. Okay? I start having transition for these states. So I'll have here 0, 0, 0, 1, 1, 1, 1, 0, sorry, and 1, 1. So the transition as follows. Since I'm assuming that my circuit has an input of X and an output of Z, here's what I say. I say I will make a transition from this state to this state when X equals 0, for example, and an output of, oh, so now notice what I'm doing here. I'm saying I'm going from this state to this state when input equals 0. And when I make this transition, the output equals as such. So notice the transition that I'm making. I'm making a transition. I am giving the inputs slash outputs. Okay, so that's how I describe the state diagram, or I draw it. So and then I say, well, I can stay in this state when the input is 1 and the output will be 0. But when the input is 0, I go to this state and the output is 1. For example, I'm just giving examples here. I'm showing you how we describe the circuit. So here is 0, 0, and here is 0, 1, for example, and here is, for example, 0, 0, 1, 0, for example. Now, notice that every every state has arcs coming from it. So every state has arcs. So this is state has every state has arc coming. So how many arcs that comes from from every state? Like for example, how many are those? Two, one? Well, it depends how many input combinations you have. So if I have input x, then I'll have to have two arcs. When x is 1 and when x is 0. When x is 1 and when x is 0. When x is 1 and when x is 0. When x this probably should be 1 here. Okay? So number of arcs that are that are leaving, or transitions that are leaving the states, equal number of input combinations. Okay, now, so this is the state diagram. Now, so it turned out the state diagram, okay, if I have a state diagram, I can, so let's say, for example, I have a state diagram that goes like so. For example, I have, whoops, sorry, let's see, brushes. Okay, so let's say a state diagram that does this and this, and then this and this and this and this. Okay, so this is called state diagram. Okay, it turned out I can represent this in a table. I call it state table. And this state table is what? This state table is, it really has the it represents the current state or present state, input, okay, and next state. So for example, let's take state 0, 0 as an example, okay? And suppose, for example, here, let's say state 0, 0, when state 0, 0 has an input of a 0, output of a 0. So I say when present state 0, 0, and let's say it goes to state 0, 1 under input of 1 and an output of 1. So here is the present state is represented by two flip-flops in my example, Q1 and Q0. How many inputs I have? X. What's the next state? Well, it will be Q1 and also Q0. And what's my output? My output is Z. Okay, so this is how I convert the state diagram into a state table. Now let's read. So here, this one here means what? It means when I am in present state 0, 0, 0, 0, and the input is 0, my output will be 0, and my next state will be 0, 0. See, my next, because I'm going making this arc. Okay, so this is one case. Let's read this other case. Now, when my present state is 0, 0, 0, 0, and my input here is 1, the output will be 0, I'm sorry, 1, and then the next state will be 0, 1. And then I continue doing this for all the states. So now you can see that the height of this table, how many combinations? Well, suppose I have, for example, in this case, it is 2 to the 3. Why 2 to the 3? Suppose I have here number of flip-flops equals M, and number of inputs, okay? In this case, I have just one input, x equal n. So the height of this table is really 2 to the n plus m. In my case, I have one input, so n equals 1, and I have two flip-flops, and m equal. So now notice that I have to do all these combinations here, okay? And that's why I have 8 cases in this table. So the point is, look at the relationship that we draw between the state diagram and the state table. Okay, so and look at the relationship. They are the same thing. They are different representation of the very same thing. Okay, so why are we talking about state diagram and why are we talking about state table? Because this is how we describe the state machine, the sequential circuit. In other words, the output of my analysis, if I have a sequential circuit here, the output of my analysis will be, I'm sorry, the output of my analysis will be state table or state diagram, one of them. Because so how, again, how do I describe a sequential circuit? By a state diagram or state table. The output of my analysis is a state diagram or a state table. So in this lecture, what we want to do, we want to get to the state diagram or the state table. That's our objective. That is the objective of what we are doing in this lecture. Okay, so let's take an example here and see how we can tackle this in your text. So now we have to follow steps, and you have to stay with me on these steps because they are really quite a bit involved. Now, let's say, for example, we have this circuit. Okay, we have this example circuit that you are given in your notes. So, and now somebody might say, wait a minute, this is sequential circuit. Yes, this is sequential circuit, but notice that they have rearranged it in such a way. They have rearranged it in such a way it is easy for you to read. But somebody might ask the question, says, you know, but we know that the sequential circuit looks like this. Here is here is here is um, here is combinational circuit. Okay, this is what we learned before, right? And then you have your memory elements, mem elements, right? And then there is something going here, and then there is this feedback coming here. Okay, and then you have a primary input and where is all of this in this circuit? Where is all of this? Well, it's very simple. We just need to rearrange things for you, and you can see it very clearly. Okay, so now where are the flip-flops? Here are the flip-flops. You have a Q1. Okay, here is Q1, which is right here, and you have Q2. I'm sorry, Q0, which is right here. Now, notice that the inputs of these flip-flops are coming from here. So you have this flip-flop has a J, a K. So this is a J and this is a K. And the inputs are coming from here. Okay, and notice that how I generate these the J and K is as follows. So I have here an AND gate and an OR gate that generates for me, okay, the J1 and K1. Okay, and then this one here, it has also a J and a K, right? And they are coming from here, from the same combinational circuits. So here we have, notice I have this and this. So I have an OR gate here, okay, and I have this as X prime, okay, and notice here these are this is this is here, right here. These are the inputs that I'm sorry, the inputs to the flip-flops coming from the combinational circuit. Okay, all right. Now let's continue now. Now the output of the flip-flops, which is Q0, right? Q0 comes in here, goes back and becomes an input here. This is Q0. Okay. Also, the output Q1 comes in from here and goes back all here. This is Q1. All right. So Q1 and Q0 are feeding back. Okay. So notice here is the feedback. This is my feedback right here. This is my feedback going back to the and you can see that I use here some of the Q1s and Q0s as for this circuit. Then then where is my primary input and primary output? So my primary input is X, which gets into here, and my primary output is Z. All right. How do I generate Z? It's an AND gate of X, Q1, Q1. Oops. Q1 and Q0 and X. Okay. So this is the, and now you say, aha, well, now it looks for me a sequential circuit. I can see now all the elements. I can see the combinational circuit. I can see the memory elements. I can see the feedback, right? Going back here, I can see the primary input and I can see the primary output. Now, why is he doing it like so? Well, he is rearranging the circuit for you. It's the same circuit. We just rearranged elements for you to make it easier to grasp. Okay, so this is what we are doing right here now. So now, so here is the question. I have this circuit. What we want to do is that we need to analyze the circuit. And to do the analysis, these are the steps that we need to do to analyze this circuit. Okay, so these are the steps that we need to do to analyze the circuit. What we need to do, our goal is what? Our goal is we need to get to the state diagram. Okay, but before we get to the state diagram, we have to go. So this is our state diagram. This is our state diagram. Before we get to the state diagram, we have to go to state table. Okay, so what we want to do here is we want to build the state table, then move to the state diagram. Sorry, this thing moved a little bit. Okay, so first of all, we will build the state table, and then we get to the state diagram. All right, so let's delete this. So our goal is what? Build the state table, and we will build state diagram. So let's build the state table. Okay, so now I understand from this circuit. I need to think about it a little bit. How many flip flops I have? Oops. How many number of flip flops that I have? Flip-flops that I have? Well, I have Q1 and Q0, so I have two. How many inputs I have? Let's see, what number of inputs I can see here? X. So I have one input, which is X. So here is a Q1 and Q0. And this one, I have one input, which is X. How many outputs I have? It is, I have one output, which is Z. It is essential that I do this analysis because it is critical for building the state table. Now, let me build my state table at this point. Oops, sorry. Okay, now, first of all, in the state table, as we said, we have the present state. And in my case, the present state is, okay, so present state, and in this case, I have the present state of Q1 and Q0. So let's see, Q1 and Q0. And then what I want is, I want, sorry, I want the inputs. So inputs here, my inputs. Of course, here I have just a single input, which is X. All right, then I have to have the next state and output. So I'm going to give myself here a little bit of a space here. Okay, Okay, so this is next state and output. So the next state will be for what? It will be for Q1 and Q0 as well, and the output Z. Now, you kind of, so, and here we need one more line here. You're kind of wondering why we have left this middle space in between. And we will see that we will use this for flip-flop inputs, so because this is necessary to get from the present state to the next state, that we compute the flip-flop inputs, the J1 and the K1, the J0 and the K0. Where are these? So you see those? This is J1, K1, J0, and K0. Okay, so, okay. Now, okay, now let's look at input combinations. So now I have what? I have present state, Q1, Q0, and input. What are the combinations? It is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1. 1, 0, 1. I'm short of one line here, and then 1, 1, 1. So let's continue this. Okay. Now, so now I have these inputs. What I need to do, the next step, now I have established my table. All what I have done is that I use the information from the circuit and I build my table from present state and next state and input and output. Now I need to find out the J and K for every flip-flop. It is clear here from this diagram that J1 equals what? Well, J1 from this diagram is very simple. I can tell it is J1 is X prime ANDed with Q0. Okay, and so in fact, I can come into the table here. Okay, so I can come to the table here and say, okay, how can I find out the value of J1? So it is when Q0 and X prime are ones. So if you look it out, you will find that the values here will be, so this is J1, K1, J0, K0. I need to align my inputs here. Okay, so you will find by evaluating this equation that this is equal to 0, 0, 1, 0, okay, and 0, 0, 1, 0. Okay, again, by evaluating this equation. Now, how about K1? Well, K1 from this diagram equals X or Q0. Okay, so you can evaluate K1 based on the values of Q1 and Q0 and X, and you will end up with K1 equals 1, sorry, 0, 1, 1, 1, 0, 1, 1, 1. Okay, now how about the value of J0? Well, the value of J0 equals what? Well, the value of J0 is X or Q1. Now, this is X or Q1. So now this is 0, 1, 0, 1, okay? And 1, 1, 1, 1. How about the value of K0? Well, the value of K0 is X prime. Okay, so I look at the X and I invert it, that's K0. So this is 1, 0, 1, 0, 1, 0, 1, 0. Okay, now, so now you can see what I have. I have now the inputs. I have learned from the previous lecture that if I have the inputs, the J and the K, I can predict the next state. Okay, so 0, 0, 0, 1, 1 0 1 1. We said, whoops, sorry, we said that the next state here is the same as present state. Here it is 0, here it is 1, and here is the inverting of the present state. Okay, so now let's take a look and see how I can do this now. So now notice what I will do. I'm now gonna look at for Q1, which is right here. I'm going to look at the value of J1 and K1. So in this case, J1 and K1 is what? 0, 0. According to the table, 0, 0 here means what? The Q stays the same. So Q1, which is equal 0, stays the same as the next state. Okay? Now, how about when J1 and K1 equals 0, 1? So I look at the table here. 0, 1 means what? It means you have to set Q1 equal to 0. You have to set it equal to 0. How about if it is 1, 1? Okay. Well, if it is 1, 1, I go to the table and it says invert Q. So I look at the Q1, it is 0. So I have to invert the present state of 0 and make it 1 for the next state. How about when J1 and K1 equals 0, 1? It is 0, 0, 0, the same as the present state, which is here equals 1, 1. Okay? And then 0, 1, 0, 1, 1, invert present state, which is here, 1 becomes 0. Okay? And 0, 1, put the next state to 0. Similarly, for Q0, I have to look at J0 and K0. 0, 1 means 0. 1, 0, it means 1. 0, 1, 0. 1, 0, it means 1. 1, 1, it means invert the present state, which is right here. 0 becomes a 1. Okay? And now 1, 0, 1, 1, 1, invert becomes a 0. 1, 0 becomes a 1. So notice that now what I have is the next state. Okay, so I have the present state, the input, the next state. I have still to have the output. What's the output here? Well, here is my output here. The output equation equals what? Z equals what? X ANDed with Q0 ANDed with Q1. So if I evaluate the Q1 and Q0 and X to find Z, I'll find this is equal 0, 0, 0, 0, 0, 0, 0, 1. Notice the evaluation happens here. Okay? Do not use these values. These are next state. You use these values. Those are the one that you use, okay, to evaluate the Z. Now what I have done? Well, what I have accomplished, I have built the state table, right? But I have here an extra stuff here, which is kind of bothersome. So I have, it's okay. I need to take out. But this is what I ended up with is the state table. Now let's take the state table and build the state diagram. So now let's take a look and build the state diagram. So from the previous exercise, what I have done, I have reached to something like this. Now this is the state table, and I need to go to the state diagram. Okay, all right. So ignore for a second this thing because this part is not going to help me. Let's understand how many states I have. So since I have Q1 and Q0, okay. Okay, so now to do this, what we need to do is to achieve to the state the state diagram. So let me organize my diagram here. I'm gonna just make these nice lines. Okay, so now we can draw our state diagram, nice and clean and easy. Okay, all right. So now Okay, so obviously I have two flip-flops, Q1 and Q0, and I have the states of 0, 0, 0, 1, 1, 0, and 1, 1. So what I do here, I will draw those. Okay, so I have four states. Here are the four states: 0, 0, 0, 1, 1, 0, 1, 1. These are the two numbers coming from the Q1 and Q0. Now uh, let's start by saying, okay, so let's see color, for example, let's take this blue, um, or maybe red. Okay, so we need now to start drawing the arcs. Notice this is in the case of when the present state is 0, 0. So I am right here now, okay? And there is an input of a 0. Where do I go? I go to the same state. So I have to draw the arc like so, from 0, 0. Now, at what condition of the input? 0. What's the condition of the output? 0. So when the input is 0, I will get an output of a 0. Now, let's take a look at this other possibility. Again, when I have an, let's see, use a different color here. Let's say, for example, um, this one here. So when I have a 0, 0, okay, when I have a 0 and an input of a 1, right? Where do I go? I go to next state of 0, 1. Next state of 0, 1. Under what? Under an input of a 1. Here is the input of a 1 right here, right? And what's the output value? It's a 0, so 0. Okay, you can see in the arcs, input slash output from present state to next state. All right, next state. Now, okay, so now let's take a look here. Present state 0, 1. Let's change color here. Present state 0, 1. Right under 0, we go to 1, 0. 0, 1. Under 0, we go to 1, 0. What's the output? 0, 0. Okay, but 0, 1, when the input changes to 1, we go to 0, 1. Okay, so 0, 1. Under the input of 0, 0, and an input of 1, and output will be 0 because here is the output. Okay, now when the state is 1, 0, which is right here, let's choose a different color here. Let's see, for example, we use here. So when the state is 1, 0, 1, 0, and the input is 0, we go to 1, 1. 1, 0, and input is 0, we go to 1, 1. What's the output? What's the output? 0. Okay, now how about when I have 1, 0, 1, 0, and an input of a 1? Okay, I'll have to go to 0, 1. Okay, I'll have to go to 0, 1, which means go back here, okay, with an output of a 0. So when the input is 1, go back with an output of 0. Now, here I am at the state of 1, 1. Okay, let's choose another color here. At the state of, let's say, for example, here, at the state of 1, 1, okay, and an input of a 0. 1, 1, and an input of a 0, you go to state 0, 0 with an output of a 0. You go to state 0, 0 with an output of a 0. And when the state is 1, 1 with an input of 1, where do we go? We go to state 0, 1. State 0, 1. State 0, 1. Here is the state 0, 1. What's the output? 1. 1, 1. Whoops, 1. Let's clean this a little bit. So 1, input of a 1, and output of a 1. This is the state diagram. This is the state diagram. This is the description of my circuit. This is the state table. This is the description of my sequential circuit. That is the result of the analysis. Your analysis ends up with a state table or a state diagram. They represent the same thing. Meaning, if I give you the state table, you have to be able to get the state diagram. If I give you the state diagram, you have to be able to get the state table. And this is the end of analyzing circuits. All other circuits are the same. One last point here I need to clarify, which is the discussion of of the mealy and more sequential circuit. So sequential circuit can be classified as mealy or more. These are two scientists who worked on these circuits. So what's the difference between the two? Very simple. If your output, if your output in for example, in my cases, the output was Z, and we say that Z equals what? Q0, Q1, and X. If the output, if the output Z is a function of the input, then it is a mealy. So here is the this is my output. Is it a function of the input? Yes. So it's a mealy. But if the output, if output, if output is a function of the flip-flops, only the flip-flops, sorry, the flip-flops, then it is a more. So for example, if for example the output was q1 q0 prime, in this case the circuit becomes more. Okay, so if the output of the circuit is a function of an input, one of the inputs, it's a mealy circuit. If the output of the circuit is not a function of the input, it's a more circuit, and that's classification of the circuits. Okay, and with this slide, we conclude the lecture 11, which is analyzing sequential circuit. Looking forward to continue with you with the rest of the lectures. Thank you very much.